Hey everyone, thank you for coming out this morning. My name is Chris McCurdy. I'm an AWS solutions architect that specializes in healthcare and life sciences. And I'm going to be speaking today with Alan Nihil, who's a DevOps engineer at Johnson & Johnson. And we're going to be talking about evolving the enterprise compliance frameworks with AWS CloudWatch events and Lambda. Now, before we get too going here, I do want to thank everyone for coming out this morning. It was a great party last night, and so it's great to see everyone here. I hope everyone had a wonderful time. And thank you for being here. So what we're going to cover today is a bit of a story of evolution. We're going to talk about, first, what are guardrails, why are they needed, and what are some patterns that we have seen as part of the HCLS specialists over the past few years, how have they evolved, and what are folks using today. And then Alan's going to come up here and talk about Johnson & Johnson and their journey that they've had, kind of migrating through these patterns, how they've been able to take parts of some and others to come up with their overall compliance picture. And then lastly, we're going to have a 5-minute demo or so where we're going to walk through building out a really quick whitelist policy engine using CloudWatch events. So we'll show how you can kind of put that together within a short period of time. Okay, so why guardrails and compliance frameworks? Being you're all here, I'm hoping this is a kind of a self-explanatory answer, right? Who doesn't need to worry about compliance these days? With all the different regulations and requirements that are out there in this world, everyone needs to make sure that their environments are up to code, up to spec, that they're meeting all their auditor requirements, all that sort of stuff. And to do that manually, by hand, by building workbooks and manual reviews and all that sort of stuff, it's just not scalable. It's not tenable. So you need to be able to build tools or buy tools that help you accomplish this and do this in a meaningful fashion or manner. Now, without going too far here, this is the AWS shared responsibility model. I think this is kind of a real key slide because at AWS, when it comes to compliance and security, we take care of everything that's, for sake of a general answer, below the hypervisor. So making sure that the physical security is good, making sure that the availability zones are good, making sure that the compute and storage, making sure that the racks are under secure, the power, the water, all that sort of stuff. But everything above that line, so making sure that you don't start up instances that have a web server running port 80 that has all your PHI or PCI content running on it and shoving that out to the world, that's part of the customer responsibility. So you need to make sure that you have some sort of an environment in place to make sure that you're protected from that happening. And on that note, here's the list as of like a week or two ago of the certifications, assurances, and attestations at AWS. It's becoming an impressive list. I mean, realistically, if we give this presentation again next year, I think we're going to need 2 slides because this is nearly unreadable. There's so many out here. And so it's really awesome. So there's lots of options that are available that AWS provides their portion of the shared responsibility model. But that also means that there's a lot of folks out there who need to make sure that they're doing their part and they can meet their part with these compliance frameworks. So that leads me to where have folks been going and how have they been evolving these sorts of things. So we've seen 4 patterns. Now, these names, if you Wikipedia them or search them out, they're not like industry standard names. These are what we call them within our little group. So they are what they are. But they really just define how these patterns are seen and how they're implemented. So let's start with API sandwich. In a way, this is a bit of the oldest pattern that we've seen within our space. And what this is imagine you have some compute instances on the left, right? You have some EC2s, some Lambdas, whatever. They want to talk to some other services like SQS and EMR, and you can kind of see the bread slices here of the sandwich. Well, the idea here is that you build a proxy layer in between. So you have an elastic load balancer in between. You scale that out with a whole bunch of API proxies. Those API proxies go through a rules store. They make sure everything's evaluated as appropriate, and then log where the results are off to the audit trail. If something's good, or if anything's good, it gets forwarded on to SQS or EMR. If it's bad, it gets terminated, and those requests are logged to the audit trail. So today, we see this pattern less and less, and the subsequent patterns kind of have supplemented it. But there's still some use cases. I was talking with a customer just yesterday who's in a world market where he's got a federal regulation that requires him to make sure that every API request within his environment is evaluated, or at least his security office has determined that they need to make sure that every API call is evaluated before it gets processed or passed on. This model totally works for that. I mean, because it gives him these advantages, right? So he can control all those API calls. He can log whatever needs to be logged. He's got that all monitored and managed. It's a very simple architecture to manage. You're just building these API proxies all the time to match all the services that you need to manage. But it's got some serious disadvantages, right? So first off, anytime a new service comes out or a new feature comes out, you need to update and add these new proxies. And we've been here, this is the fourth day of the conference. There's a whole lot of new features that are always coming out. So that's a huge workload, and you have to basically keep pace with Amazon to make sure that you're providing all these proxies. That can be quite a task. Secondly, you have the cost associated with scaling out these API proxies. You're gonna build all these proxies out. They need to handle your entire workload, so you have a bunch of kind of middle architecture that's not really providing business value that you're gonna have to scale up and associate with that cost. And then probably the most important disadvantage, or the kind of the deal breaker that I've seen with folks, is that indirect service access causes variability. As soon as you put this man in the middle, this service in the middle, all of a sudden you've added this tiny bit of uncertainty. Now you're gonna see really odd things that happen where all of a sudden you're routing through this proxy layer, you're gonna get the occasional drop, the occasional issue. And to be honest, it's hard to debug. So now you're trying to figure out what just happened. This worked 99.9% of the time. Now we have this one case. So you end up spending a lot of time and resources and headache that's associated with that. And then lastly, being you have this proxy in the middle, anytime these new rules come out, like again, with all these new services that came out with AWS, you have to upgrade those, which means you have to take down this man in the middle. That's gonna impact your business flow. You have to create these outage windows so that folks aren't getting impacted, that they're not, you're not taking away, your customer experience, that sort of stuff. So it can be a huge hassle just the same. So that's evolved. We've seen that evolve most commonly over to what we call periodic describe. The idea of periodic describe starts really simple. Let's remove the services in the middle. Let's get rid of those. That's causing us pain. That's causing us havoc with those disadvantages. But when we stop and look, we're like, well, geez, we're not really doing compliance now. We kind of dropped the whole compliance thing off the side. So that doesn't really get us what we want. So what you do then is you build out a compliance layer that sits on the side. So you'll have something like a resource describer that sits over there, periodically pulls all the resources in those VPCs and accounts, gathers that all information, maybe it queues it up through an SQS queue so that it can be managed out, it can be fanned out, whatever's appropriate there, and then send on over to an enforcement engine that can make that decision based on the rules that says, do I kill this instance? Do I shut down this S3 bucket? Do I do whatever I need to do? It uses that rule store to go through and enforce that sort of thing. And of course, log everything off to the audit trail so you have a great comprehensive audit as to whatever's taking place within that environment. So this is still pretty common. We see this with folks who have a lot of resources outside of AWS. You can build this architecture such that you can span your on-prem as well as AWS. You're scanning those resources as long as you can kind of get the equivalent of a describe and that sort of thing within your environment. Also, folks who have application compliance, they want to make sure their applications are configured and set up properly, all that sort of stuff. They're still using this model as well. So we're seeing some good stuff there. Some advantages, again, as mentioned earlier, direct service calls. We no longer have this proxy in the middle that's causing havoc. And it's also easy to add new rules. We added a little buffer there with the SQS, right? So you could shut down the inside, add new rules, bring it back up, SQS buffer, pull it back through, you're good to go. Now some disadvantages, depending on how you implement this, if you have a lot of rules, imagine every rule that it invokes is going to go off and periodically describe a bunch of resources that are associated with that rule, right? When you start doing that, you start getting this kind of compounding math of API calls that takes place. So you'll have like your number of resources times the period, which equals your overall API call overhead. At some point, you're gonna hit the AMI API limits. And so when you start doing that, you're gonna have other users who are in the IAM console, and all of a sudden they're gonna start getting, whatever the 500 number is for the AWS limit reached. And so they're gonna start getting weird behaviors, things like that, and it's not really a great experience for your folks who are using that. And it's just really an artifact of the way this architecture is set up. Next disadvantage, you're still having these compliance instances that are running, so you still get the cost that's associated with that, so it doesn't really help that. Also, being this is periodic, right? So we're talking executing this every 5 minutes, 10 minutes, hour, 2 hours, day, month, whatever. There's this window in between there where you could have out of compliance activity, right? There's, in theory, someone could stand something up within that period. They could lose work. That would be the worst business value, right? They could stand something up, start working on it, deploy whatever. All of a sudden that instance gets killed. they're not going to be thrilled, right? The other case is maybe you don't have maybe there's some NACL issues or something, but they stand up a server, they open on HTTP port, and they are sharing data they shouldn't be sharing for 5 minutes, something like that. So those risks can be managed and they can be controlled, but there's still risks, right? So you still have that to worry about, and it's still a bit of concern, so it's a bit of a disadvantage associated with it. So we've seen that evolve now, most recently, since CloudWatch events have come out. So you can kind of see an evolutionary period here. But again, none of these are mutually exclusive, so you see based on use cases, all sorts of folks are using both of these. We see it has evolved now to event-driven workflows. Now, event-driven workflows start the same. Again, we don't want to introduce that proxy in the middle problem, so you have your EC2 and Lambda instances, and again, just examples, talking over to SQS and EMR. From there, they generate CloudWatch events. So CloudWatch events are basically events that are tied to the AWS services or API calls that generate off that say, something has just occurred, here's the information about that event that just occurred. That event gets generated, sent on over to SQS. SQS, this is kind of an interesting thing. What we found is that those events in and of themselves work at a baseline, right? So making sure that you have the right instance type, making sure you have the right region, that's all pretty good. But really, when you're evolving these compliance engines, the next level is making sure that you have the right cost center, that you got the right project ID, all these sort of business concepts that you end up needing to enrich on top of that. So we see this sort of enrichment, the event enrichment layer that takes place at both an instance and at a sort of aggregate level. So there's this layer in between using a Lambda that goes through and enriches those events with whatever is necessary. And we'll talk about that more in a little bit. Those events then get sent on over to SQS. Again, we have a compliance enforcement layer, so they get buffered up there. Enforcement engine goes through, evaluates what's good, what's bad, all that sort of stuff. Anything that's bad gets killed, anything that's good gets recorded. There's also, of course, a gradient there as well. You can also send emails, you can do whatever you need to do for your policy. The key thing is that you're taking that action and you're aware of it. Another thing, not sure if I mentioned this, but all these are now Lambdas, right? So you're only reacting to these events when these events occur. So you no longer have these instances that are up and running for hours or days at a time, right? You're now having them stand up every, whatever period you want associated with that SQS queue. They're pulling off the queue, running there whatever they want to run. Your costs are really controlled because you're using those Lambdas. Now, use cases. So a lot of folks who are like all in AWS, who have a good footprint within AWS, they're seeing it as really handy because they've got all these resources here. They're already generating these, or they can generate these CloudWatch events. They can build this out without too much hassle. Also, using custom events, we see folks with applications. They can set up their applications. Those applications can generate custom events. Those custom events can feed in. They can be all part of this standard workflow and follow the same exact architectural pattern. Advantages, still direct service calls. That's great. Another advantage, now action is taken in milliseconds instead of minutes. So these events, as soon as the CloudWatch event gets generated, it follows up all through the workflow. The evaluation or enforcement engine can act on that, kill that instance, even before you even realize it's up. So it's already taken, you don't have that chance of loss of work, and your risk window now is milliseconds opposed to minutes. So much more managed risk. And then as I mentioned before, Lambda, using that can substantially reduce your risks. Again, you no longer need to scale up this infrastructure and maintain all these instances that are running for long periods of time. Now, disadvantages, admittedly, of the architectures we've covered so far, this is probably the most complicated architecture. You know, setting up these Lambda jobs and these CloudWatch events and chaining them together. And so you have to have kind of a bit of an understanding and a good practice to be able to implement that. So it's certainly one disadvantage. Another one is, if you're using this CloudWatch events, oftentimes, again, they're pretty thin events. So you're going to see like, and Alan's going to show an example of one in a little bit, but you'll see that they're pretty thin on what their content is. And so oftentimes you might actually need to describe still. So you might still need to do a describe to find out what the availability zone is or something like that. Now, granted, in this case here, it's only when these events occur, so it's not occurring every minute, hour, whatever that's associated with it. It's only when someone stands up an instance, shuts down an instance, whatever, S3 bucket. So you've reduced that cost. You no longer have that high window of math, but it's still a disadvantage. Another thing is, so there's another service out there called config rules. So config rules also can go over, monitor your services, and generate these rules events, which are kind of akin to what these CloudWatch events are. Those are very rich events, and so those could actually remove what the describes may be. But config rules comes with another disadvantage, which is it covers less services at this time. So maybe down the road, config rules comes in and provides more comprehensive for what you need to do, or maybe CloudWatch events is sufficient to you. The nice thing with this architecture is as long as you have an event emitter, the architecture stays sound. So you can replace that piece out with whatever you want to do to generate that emitting of events, and your architecture stays good. It's very, very modularized, so you can just plug and play. Now the last one here. This is kind of a different take on things. This is predefined resources. We're going to take a kind of a different look at it. So, and this is kind of a more holistic environment kind of perspective. Now, imagine if you have an environment where you have a security compliance admin and developers, and you want to make sure that everything is tightly controlled, that you have basically your environment in the form of stamps. So you can go in and stamp out, this is what I want our 3-tier web architecture to look like, and we don't want variance on that because we're a validated environment. We've gone through whatever compliance and regulations are required for that, so we want to be able to just stamp it out. How can we accomplish that? So what you can do is use this sort of pattern here. So you have the security and compliance admin who can wander through and use AWS CloudFormation templates, define what that 3-tier architecture looks like, or whatever that architecture is that they want to implement. Take that template, upload it to Service Catalog. So now you've defined what this option or whatever these architectures are that are available in CloudFormation, so folks can then start browsing it. You have your developers who are then using AWS Code Commit. They're using, they're developing whatever application, maybe their local environment, they're making sure it's up to snuff, all sorts of good stuff. Whenever they're ready to go to development or test or wherever they need to go, they can go to the Service Catalog, browse, find that template, find that architecture they're looking for, instantiate it using Service Catalog. That creates a stack, which is the implementation of that CloudFormation template. You can have that stack pull from code commit, so the developers never need to log into the instances. And that's a great situation, right? If you can have these immutable instances where the developers never need to log in, they become a lot more secure and a lot more stable. So this can go through, pull that code out, wire over to CloudTrail, so making sure that all of the services that are associated with that are logging all of their logging all of their audit trails over to a compliance bucket, so your audit folks can go through and see what the health and state of the system is. It can also wire in with CloudWatch. So now you can set up monitors to make sure the environment is healthy and in good state, all that sort of stuff for you automatically. Also can tie in with config. So config can go in and show you what the current state of this entire environment looks like. What are all the instances that are up and running, EBS volumes, all that sort of stuff. It can also tie over to CloudTrail. I don't have that arrow depicted here, although I think there's plenty of arrows. So that config can navigate over to CloudTrail. So now you can see, when did this configuration change? Who changed it? And that sort of thing. So now you can ask that question of why did it change? So you get that kind of holistic compliance picture. It can also, CloudWatch can trigger alarms, right? So if you have particular events or bad things that are occurring, you can go through and trigger an alarm, which then can notify your security and compliance admin. So they can go and take action. They know that something's bad, and they can do their job, basically, making sure you're in a compliant and pretty healthy environment. So the nice thing at this, if you really take a step back and you look at it, from a security and compliance admin perspective, as well as the developer perspective, they're just interacting with a few resources, right? CloudFormation, maybe Service Catalog, Code Commit. All the rest is the infrastructure that makes sure that everything is stamped out in compliance and meeting whatever they need to meet. Now, some use cases here. Again, highly validated systems or environments where you need to make sure it's highly constrained and you don't want a high amount of flexibility, perfect setup for it. So some advantages, again, environment conformity, so you make sure that your environment matches whatever your expectations are, not much flexibility. High RI utilization, so a lot of customers want to get to an RI utilization of like 95, 100%, which, in a normal on-demand or a highly scalable architecture can be hard to get to. This here, if everything is stamped out, all of a sudden you now know what your environment's going to look like. You can meet that high RI utilization. Thirdly, only defined activities, i.e. that are allowed within this framework, that are within this, the CloudFormation templates, all that sort of stuff, are possible or allowed within this environment. So highly controlled, highly managed type scenario. So some disadvantages, and I've said this probably too many times, you get less development freedom, so it's just a trade-off, right? So there is no free lunch. So if you want to start stamping out these environments, that's a disadvantage that you have to go with. Now, what I've just covered, so a colleague of mine, Chris Crosby, went through in a 4-part blog series in awesome detail where he goes in and breaks down this whole stamped out environment. So if that's something that interests you, I highly recommend you read this blog posting because I think it'll really dive into a great detail for you. Now, I want to bring to the stage Alan Nihil. He's a DevOps engineer with Johnson & Johnson, and they've been going through their own evolution path through these compliance engines, and so I'd like him to talk to you all about it. Thanks, Alan.
All right. Good morning, everyone. So before I start to talk about our compliance policy and what we built, I'll talk a little bit about Johnson & Johnson, what we do, sort of our journey to the cloud, not so much as why you want to go to the cloud, but what we did to get there, because that's sort of going to help explain why we built what we built, the way we did it. And then I'll walk through what we had before and what we've been working on recently for our new engine. All right, so Johnson & Johnson, a lot of you may know it for Band-Aids or Johnson's Baby, but we're a global healthcare leader. We're leaders in the pharmaceutical, medical device, and consumer space. So we have 250 operating companies. Those are business units within Johnson & Johnson that sort of act on their own. So they have their own IT organizations, things like that. And we're in 60 countries in the world. So we have operations, a footprint in 60 countries. So think about that sort of scale. And we have over 126,000 employees. So if you think about that, internally you could develop an application, launch it, go live, might not even be exposed to the internet, and you could have over 100,000 users. And then in 2015, we did over $70 billion in sales. So you can see that we're kind of a pretty massive company. And with being a big company, there's some pretty big challenges. You think about our IT operations, trying to coordinate everything, 60 countries, different time zones, different languages, not to mention 250 companies. They might all have their own initiatives, different applications that they're building. And you think about mergers and acquisitions. So they might have come in with their own Active Directory, different users, all that stuff. You have to make all that mesh and work. It's a regulated environment. So we have obviously HIPAA patient data, we have PII data, and we also build regulated applications. So we have applications that monitor manufacturing, laboratory. So those kind of things we need to make sure we keep secure and compliant. And I mentioned this before, you think of demand forecasting. 250 companies, each of them are working on 100 different applications initiatives. It's 25,000 things that your central IT is trying to plan for. Think about the changes to deadlines, timelines, what they'll need, different demands. Trying to get that and rack and stack that's nearly impossible. So because of that, Johnson & Johnson decided to go to the cloud. Part of our initiative to go to the cloud was internal, was also public, so public cloud, and we created what we call the virtual private cloud team, or the VP6 team. That's what I'm a member of. So as we went to the cloud, we wanted to come up with a vision. Sort of how do we want to do this? Because we knew we kind of needed to do this differently. If we just stuck with, one AWS account with central IT managing it, yeah, we'd sort of alleviate some of the pains of, hey, we don't have enough servers, but really it doesn't give those teams the agility that we want them to have. So the first thing was enable agility, right? The cloud allows you to scale up, scale down, do all this awesome stuff, a couple clicks near, whether it's minutes or seconds that you get those resources that you need. And we wanted the end users for IT, the business unit IT, the application developers, engineers, data scientists to be able to do that on their own when they needed it. We wanted to accelerate best practices. So if you think of key rotations, monitoring, anything like that, stuff that we can now as a central team script out and just either apply it or share it to those groups, making it really easy for them to do the right thing. And then we wanted to enforce policy. So not only are there government and country and state regulations that we also have our internal compliance and security controls. So we wanted to make sure that all those resources, all those accounts, everything living within it, we're adhering to those policies. And we wanted to do all that while keeping it self-service. We wanted these teams, these end users, to be able to log into the AWS account, their console, click on EC2, click the server that they need to provision, and provision it. Not submit a request somewhere, have it wait for a week, get kicked back for some reason, and go through all that. We wanted them to just use it as they needed to use it. So to get there, we came up with some core principles. First one is least privilege. You've probably heard this a lot in different security compliance meetings. We wanted all the users and all the resources to just have enough privilege to do the job that they're required to do. No more, no less. Account isolation. So this is what might differ us. It did originally, more companies are starting to do this, but we have a lot of Amazon accounts, hundreds, soon to be thousands. And each of those accounts gets its own application. This is really awesome for us. If you think of IAM, we create users, We say, okay, now they can work on these EC2 instances. We don't have to worry about them terminating a different application or making a change to someone else's environment. And we wanted to make going to the cloud really, really easy. We wanted it to be an extension of our network and our current identities. So you think of like Active Directory. We already had the tools and policies and procedures in place for that, and people were familiar with it and they liked it. So we didn't want to change that. We wanted to make it really easy for them to get started, get into the cloud. And if we had to go through an audit, it would all be the same systems. And then lastly was verbose logging. So everything's now an API call. We get all this information with it. And S3, it's 3 cents a gig a month. Glacier, it's 1 cent a gig a month. There was no reason for us to not save all that. So we made sure we logged everything wherever we could, and we held on to it. So we came up with 2 types of controls. We call them preventative and detective controls. So preventative controls, the easiest one to think of is what we call our IAM whitelist. So every IAM user that gets created in one of these accounts gets this whitelist applied to them. And it's really just a deny not action policy. So if you think about that, deny not action, anything that's not listed in there, they can't do. So you think about giving self-service, that's one of our controls. We don't let them modify that policy, it's always applied to them, and they can't do anything outside of that scope. We also did a little bit of a combination, like Chris mentioned. You might be using a combination of all those different patterns. Predefined resources, so our networking, so you think of the VPCs, the direct connect set up with them, security groups, all of that's defined through CloudFormation or some way scripted, some sort of scripted fashion form that we have control over, that they can't modify. This makes it really easy for us to have certain control. We know what VPCs are in the accounts. We know where to look for the resources. We know what VPCs they should be operating in. We know where those VPCs are connected to. Backups and monitoring. So we, again, this is sort of that best practice stuff. We take the backups for them. We enable the CloudWatch monitoring for them. And we do things like block them from deleting their backups. That way, if someone makes a mistake, deletes a server, we know that they didn't delete the backups. It's there for them to restore from. Again, I mentioned that AD integration. So we have our Active Directory, and it's just sort of synced to the accounts that we have using this tool I'll talk about later. And so those are preventive controls, and those are pretty rigid. So sometimes, they might not have the granularity you want to sort of set up what you're kind of looking to do, or it just might not make sense to, right? You start to put together these really complex IAM policies for every different account, all these different one-offs. It gets really, really tough to manage. So we came up with detective controls. Detective controls allow us to use our application and a lot more of our code base to describe something, figure out how we want it to look, and then take some sort of action or do something with that information. So you think of segregation of duties, right? What sort of groups or what policies, what roles does this user have? And is that sort of okay? And making sure there's checks on that. Encryption. So any resource that's brought up that we can encrypt, we automatically make sure that it's encrypted. If a user didn't do it, we'll do it for them. Logging enabled. You think of someone coming through and provisioning like an ELB, right? There's the option to flag it, make sure it's the logs are getting dumped into S3. If they didn't do that, we'll do it for them. Or you think of logging retention on like an RDS instance. We make sure it's set to the maximum. And then I talked about this already, approve VPCs. When we create an account, we go through, we delete all the default VPCs, we create our own that are connected back to our on-premise network, and that's where the teams need to provision resources in. They try to provision anything outside of those VPCs, we'll kill it. So how do we get there? So I'm going to talk about our application that manages all this for us, and it does a lot of other stuff too, which I'll talk about. And actually, Andy Jassy gave us a nice shout out on Wednesday for this, and that's called XBot. So first thing that XBot does for us is our policy enforcement. That's sort of what I've been mentioning before with those detective controls, making all these describe calls out, figuring out what resources are there, what their configuration should be, and correcting things if they need to. Administration. We also, as the VPSec team, the central cloud team, that gives us our hooks into all the accounts in case something goes wrong. We need to go in, look around, see why something's misconfigured, or maybe change something for a team. Database. So we have this unified database management layer across all of our DBs. So when an RDS instance or Redshift cluster gets spun up, we detect that. We actually take over as master user and then layer our controls inside the database on top of that. So XBot's handling that for us. The console. So not only does it give users federated access to the AWS console, we also have our own console, which is part of XBot. That's where they can click on the button to federate into the account. We also show them metadata about their account. Hey, what cost center is this going to be billed back to? Things like that. And that's where the billing comes in. So you think of the AWS billing, obviously there's a really nice portal for that, but you might have third-party integrations that you're applying to all these accounts that you want to show the teams what those costs are for that. You can do that through our console. Active Directory, I sort of mentioned this already. We define everything in Active Directory. So all the accounts have their own AD groups, and anything on top of that you think of OS level DB access has corresponding AD groups, and we read from that to actually assign the permissions to the resources. And then ticketing. It's really important when you're doing this policy enforcement, you think about, hey, someone spins up an EC2 instance, it's wrong, you terminate it. They might come back and look at their account and say, why was this terminated? Now they go to CloudTrail, they see some weird username, they say, I don't know what's going on. Maybe they didn't read the articles that you had published for it. You might want to send them some sort of notification saying, hey, just so you know, we terminated this instance on your behalf because it was misconfigured in this certain way. This is how you should do it to do it properly. All right, so let's take a look at how we had this originally previously designed. So on the right, you'll see we had all these application accounts, 1, 2, 3, infinite scalability, right? And we had XBot, which was living in its own AWS account per our design patterns. So Chris talked about this before. We were doing the periodic describe method, right? So we had our test workers, and we had our metadata stored in DynamoDB. What we do is at every interval, so we'd have a scheduled task going, it would read, like do a scan of our table, get all the accounts that we wanted to run a certain suite of tests for, and then queue those up. So the test might be like, one of the items in the queue might be, okay, I need to test account 1, and I need to test all the RDS instances in it. A worker would pull that down and say, okay, RDS, okay, that's fine. What regions are enabled for the account? Okay, take those regions, that same test suite, and put it back into the queue. We'd re-pull that down from the queue. The worker would get it and say, okay, US East 1, RDS. It would make the describe out to that account, say, what are the RDS instances in this region? Take that list back, re-queue it back up. Another test worker would pull that down and say, okay, this instance, this region, this account, test against all these, whatever, these 7 tests, and then it will do the evaluation. Anything's misconfigured, it takes some sort of action if needed, send out the ticket. If not, everything passed cleanly, that's fine. And that worked really well for us. Chris sort of mentioned some of the pain points, but the other one, you gotta think through this. If you have an EC2 instance and you wanna make sure it's an AMI that you have, right? You might have a golden AMI that you publish all the accounts, and you wanna make sure your teams are using that. You don't need to check what AMI a server is every 10 minutes, right? That's not gonna change. Once the server's live, that's the AMI it was provisioned with. So if you constantly have, if you have 10,000 servers and you're testing that every 10 minutes, and these servers are a year old, you're just wasting resources. So we knew we needed to change it. Part of our design considerations were, do we want to do this distributed or keep it consolidated, right? Do we want to take that policy engine and somehow bundle it up and put it in every single one of our application accounts, or do we want to keep it centralized? Well, if we distribute it, that's awesome because now those teams are paying for the costs, right? The Lambda job, the Lambda functions, EC2 instances, they're running that account, they're paying for it. It's also nice because it's for scalability, right? You think, okay, instead of having one application that needs to scale to handle our tens of thousands of accounts, we can just have one application in that one account, and it just has to scale for the resources within it. But there are some problems with it. Lambda, right, to execute on a resource in a VPC needs to be inside that VPC. Or same thing with EC2, right, you have to run in VPC. But not all of our accounts have VPCs. Some of them just have S3 enabled. We don't put a VPC in there, we don't waste the IP space. So that didn't really make sense for that design. And if we have, a team might have a couple S3 buckets and maybe one small EC2 instance running in their account. If we go ahead and put like an M4 large in that account, that might now become the majority of their costs. We didn't really want to do that to them. So we decided to keep it centralized. Keeping it centralized is also really nice. All our logs are in one place. It's easy for us to handle it, scale it out, and keep an eye on it, make sure everything's processing as it needs to be. So what do we do to change it? Well, we went to events. So if you take a look at what a current app looks like, it's really simple for us to do. We actually, you use CloudWatch rules and we deploy them in the account. So you might have your resources, you might have EC2, RDS, EMR, S3, all those resources in there, and you can configure what events you want to trigger off of, right? EC2 run instance, someone created a new server, you can fire for an event and say, okay, I want to check it against every one of my things for that type of event. S3 buckets created, same thing. So we just used CloudFormation, really easy for us. We deployed an SNS policy, an SNS topic, and then just our rules. And every time those rules are triggered, the target's going to be that topic, and I'll show that here. So you see, it's a little bit small. You can see the event pattern, so you'll have basically what was the event source. For this one, it's EC2 run instance, so it's EC2. And what was the event name? Run instance, someone launching instance. And you can see at the bottom there, the target, the SNS topic. So every time that API call is made, it's going to fire off and publish to that topic. So what's this look like at the bigger scale? So now we have all these different SNS topics in all the different regions, and they're just publishing into our one events queue. Before I sort of showed that we just had that one queue and we were re-queuing to that queue and pulling from it constantly. There's a few reasons that's a little tough. Before we didn't have FIFO, so and there might be duplicates. So we were doing this weird caching thing to make sure that we weren't creating duplicates within the queue, and to make sure that we were trying to pull them down in some sort of order. It also makes it really, really tough when you're trying to go back and say, okay, how many events did we fire? What did we check? You say, okay, well, what percentage of them would have been us re-queuing something? And it makes it really difficult to look through and try to understand how your application's running. So we decided, okay, we're gonna try to keep it modular, break everything up into more queues. So all those payloads, those events are just gonna be fired into one queue. We still left queuing in there because we wanted to have that as sort of flow control. Give us time to scale out and handle that queue. If someone launches 10,000 instances, right, we need to maybe have some time to buffer to handle that. So we pull down the event, and basically I'll show some code in a little bit, but we're just saying, okay, what was the event and what was the source, and what should we do with that? We'll take that, so the workers will pull that queue, pull that down, say, okay, it was EC2 run instance, okay, and it'll say these 5 tests need to be executed, and it'll queue those up into the test queue. And then test workers will pull that down and just execute those tests for us. So it's a lot cleaner, and it gives us a little bit more control and insight as to what's going on. And at the bottom there, you'll see we have an audit queue. The audit queue is actually almost exactly what we had previously. The reason we kept the audit queue, there's a few good reasons. Your security partners might come to you and say, hey, we want a full run of the environment, and we want to show that it's a clean right now. Okay, we can just trigger that up through our audit queue. Or you might have bugs happen, you might have deployed a bug, and you need to go back through and re-trigger some things to correct it. Or you might have updates you need to make. You think of S3, if you're defining what IP addresses can connect to that S3 bucket, and your company now has a new public CIDR block, you need to go back through and add that to all those bucket policies. Well, yeah, you could write a custom function and script to go ahead and do that, or you could just update what your defined template is and just re-queue that to the audit test. And we kept it as a separate queue, again, because we wanted to make sure that we had the visibility into what's going on with the metrics. But we also didn't want, and if we went through and queued up 1,000 tests in the audit queue, we didn't want that to slow down the live processing of something from the event. So what do these events look like? All right, so you'll see, first thing you'll get, maybe an account ID. That's really helpful, especially if you're doing things across multiple accounts. You'll get the region, you'll get the source, in this case, AWS EC2. You'll get an ID, so that might be helpful for you if you want to store that somewhere. You might be doing metrics, you want to track it through some sort of full-length process. But really, at the bottom of that payload, you'll start to see the good stuff. You'll get the VPC ID, the instance ID, the AMI ID, the subnet ID. But as Chris mentioned, there's some stuff that might be missing. So in our case, subnets, we define a lot of that through tagging. So it's not, those tags aren't coming in. So you might need to do an additional describe call, say, hey, I know the subnet ID. Okay, that'll make it an easy call, but I still need to go back out and get the tags for that subnet. And what do you do with this? Well, you'll have some sort of function that will pull from the queue. And then at the bottom, you'll see some light code is what you can do with it. You can say, okay, well, what was the source? EC2, okay, send that to a function that's going to define all my EC2 events. That can go through and say, okay, I need to know what was the API call that was made, and then I can trigger that up to another test that'll kick off the different suite of tests that need to be executed for it. So you see it's really, really clean and really, really light, and by using code, it gives you a lot of control over what you can do with it. Not only here can you send this to be processed to your test queue, but there might be other things that you want to do. Maybe you're not a traditional company, but you still have a CMDB somewhere, and you say, okay, someone just launched or terminated an instance. I need to update the records in my CMDB to reflect that. Or, hey, this instance came up. I want to send it off to a different path to be either, do something with Active Directory, set up some monitoring for it, some my CloudWatch alarms, those sort of things. So it's nice to keep it modular. And so for our test code, we actually use Python unit test framework. And this makes it really, really easy for us. So we can just say, okay, from this event, I got the VPC ID. Maybe for that account, in my metadata, I have the list of VPC IDs that I've created and I know are valid. Is that VPC ID in that list? If it is, awesome. If it's not, we need to terminate that instance. And that'll kick off that chain of events of making the call to terminate it, creating the ticket, letting the user know, all that fun stuff. So what are some of our lessons learned? So in software development, there's a rule, sort of rule of thumb for how you scale out your code. It's the 0, 1, or infinity rule. We did a really good job with that with our actual code, but it's something that we might not have done a great job with initially of thinking about our application, right? Should this handle 0 events, 1 event, or infinite? So as we went through and we decided to reconfigure this and scaling out, that's something we really need to keep in mind. So I mentioned buffering, using queues to buffer that. You could get into some trouble if you said, okay, I have all these SNS topics and they're going to directly fire a Lambda function. Well, that doesn't give you any control. If you have 10,000 events going on, you could hit the Lambda limits for that. And then how do you handle that? Keeping your code in your application modular. So this is huge for us. Obviously, you want to keep your code modular, make it easy to maintain and update, but keeping your application modular as well. I talked about how we had separate queues for everything, sort of breaking apart the application as much as possible. It's really good because then you can tie into things like the metrics that already exist that Amazon provides, but it's also really, really good in case they release a new service that you want to use, right? You don't have to redefine all of your application at once. You can take that one little piece, switch it over, make sure it works, deploy it, awesome, and then move on to the next one. So it makes it really, really, really easy to do that. And that sort of ties to the next one is using paths and avoiding technical debt. Yeah, we could have had that event fire to a Lambda function within the account and then taken that, done some manipulation of it, and then sent it to the queue. But why? We don't want to deploy the code to all that. SNS is just going to fire it up for us, and we'll handle it there. It's much, much easier. Same thing with CloudWatch events. Could we have done this another way? Yeah, we could have had the CloudTrails be logged to a central account and then scrape all the logs. That's a lot of code and a lot of resources we have to maintain. I'd rather just use CloudWatch events, lightweight, CloudFormation deployment, really easy to get that information back to us. And then one other thing that we learned was differentiating between test frequencies. So I showed sort of that unit testing framework. Initially, we had 2 test frequencies. We had 10 minutes and every hour. And I mentioned before, well, that might not make sense. You have an AMI, right? I don't need to test that every 10 minutes. Maybe, depending on what my security partners want, I'll test it daily or weekly. So what we did is, when Python unit testing is nice, you can actually nest unit tests. So you can make a suite of unit tests and then make a suite of suites. So we went through and defined it, said, okay, we can have suites for every test that need to be executed. 5 minutes, 10 minutes, 15 minutes, hourly, 6 hours, 24 hours, weekly, whatever that may be. And then we can just group those tests into those suites and execute them. So, a resource comes up, we'll probably execute all the tests against it. But then as we go back through and we have our audit tests running, we can have a different frequency. And that's important because sometimes there may be gaps in your predefined sort of policies. So you think about when we take over an RDS instance, we can't block a user from doing everything. There's certain things that we want them to be able to do on the database. We can't really block them in a good way. Or you think about EC2. Yeah, we control the security groups, but we don't control the teams, which ones they're using on an instance. But there might be security groups that open up a server to the internet. And that should only be applied to certain servers, maybe like a WAF, right? So we can check that and say, okay, what servers have the security group applied to it and correct it. But that we would do, we can create an event off it, but originally you might want to do that on a periodic basis as well. And so that's been huge for us because, again, as you're queuing up all these tests basically all the time, you want to be able to queue them up as infrequently as possible because that's going to save you costs. And with that, Chris is going to come back up and he's going to walk through a demo.
Thanks, Alice. That was awesome. Thank you very much. All right, so let's take a look here. So we've got a DynamoDB table, and we can see pretty basic here. So we've got a project ID, so we want to allow all projects with this particular ID to be able to create instances. We want to allow them to be able to create T2 micro instances, and maybe M4 mediums, whatever the list of whitelisted instances you want, and only in US East 1C, I should say. So if they want to do anything else, that's probably not going to work. Okay, so with that in mind, let's take a look at some Lambda here. So Alan showed some great examples. So let's go through here to, I apologize, I have to look over here. Instance decorator. Okay, so we talked about this before, where you have to do some level of instance decoration, right? So what you can see here, starting at the bottom, because this is Python code here, what we're going to do here is we go through, we're going to query that instance because we want to get a little extra information. We mentioned before, there's not the availability zone as an example. And so if we want to make sure that we filter on that, we're going to have to call a little describe, so that's okay. So we can call our EC2 instance information, get our detail out, create that decoration. So we're going to pass on what's the instance ID, what's the image ID, what's the placement, that's where your availability zone is going to be, whatever's necessary for your compliance world, right? Decorate that out, get that decoration there, send the event on, forward it on. We're going to use SNS now instead of SQS just for the sake of this demo. We're going to forward that on to what our next Lambda job is going to be, which is going to be our more of our project decoration. So let's take a look at that. So aggregate context decoration. So a bit of a conceit here. So we could have gone on and written a DynamoDB with a whole boatload of tables and projects. Didn't really seem worth the time. So we're just going to call all projects that get created alpha. Problem solved. So that check is probably going to pass. But we're going to go through here. We just generate that, or we gather that message out of the CloudWatch event stream, or out of the SQS stream, or SNS stream in this case, I guess. Take that, decorate it up with what we want now, which is the alpha. So that's more decoration on top of the other decoration that we had before. Take that along, forward that along for evaluation now. So now from an evaluation standpoint, we have in here our, let's see, enforcement. So start again at the bottom. There we are. Okay, so we're gonna go in, we're gonna pull that record out, do a little printing so we can debug it, go through and then just make sure, is this project valid? So now we have a full message, right? So we have the project definition, maybe you wanna include your cost center, all that sort of stuff. We have all the instance information, your AZ, your image, all that sort of stuff. So we're gonna take that packet of information and pass it on to an evaluator to determine if it's good or not. So we have up here our is project valid, which is pretty simple. We're just gonna go through and make sure that in our DynamoDB table that list of instance types is allowed, as well as the availability zone allowed. Do we match our requirements that we wanna match, as well as, project information. From there, we go in and we just, if it doesn't match, we terminate the instance. Otherwise, we send on a message to another message queue that says, hey, this is passed, this event is great, we started an instance, someone can go take notice, maybe they need to bill, whatever they need to do. So they can go and run with that message. So that's from a coding standpoint. Again, it's a whitelist instance-driven model here, but that's about it. You can extend this really easy to doing S3, to using any of the other services, and go and kind of build this out into your own policy framework using CloudWatch events. So the last step here, let's go into CloudWatch. So if you want to set it up to trigger this whole chain of events off that we've just talked about, you can just go into here, CloudWatch rules, let's create a rule. Now in here you select what your event source is. So again, so here's the big list as well as the kind of global AWS API call. So if whatever you're looking for is not in this list, you could certainly just scan for whatever API call you need. But for our case here, EC2, you can also check whatever state you want. So there's a whole lot of states, in this case here, EC2, running, pending, shutdown, et cetera. We're gonna keep it simple, any state, any instance, we're not gonna refine that either. And if you're curious what these events are gonna look like, you can certainly go here and take a look at it. This is similar to what Alan showed earlier, what these events look like in detail from a sample perspective. But now we're gonna add a target. So we're gonna add a Lambda function here. We're going to call our instance decorator. We don't need to set a version. We're going to keep that, again, pretty simple. Go through, add the target. Oh, so that's it added by default. Then go down and save it. Where is the save? There we go. Configure details. We're going to call this CWE monitor. Reinvent. Cool. Click create rule. Okay, with that rule created, we can look down here. We see the rule there. That's great. So now let's cross our fingers with the demo gods one more time. So let's go ahead here. Let's create an instance. Let's go in here. What am I? Make instances, launch instance. Okay, so let's go in here. Let's just pick an image. We're not too concerned with that. Let's start with something pretty wild. Let's go with maybe M42XL. We're not going to worry too much about configuration and details for our demo, so we're just going to launch it. Set us up on over here to our reinvent key pair, acknowledge, launch instance. Okay, so we've launched that instance. That's cool. We can go back, view instances. It's now launch instance here. It's still processing. So we'll go in here, launch an instance. Now let's launch a T2 micro. So we know this is part of our allowed list. That was part of DynamoDB. And we also know that we are in US East 1C. So this matches all of our expectations. Go in, launch, key pair, reinvent demo, yes, acknowledge, and launch. Okay, so now let's go back to view instances. Now if we take a look here, what we should see is our T2 micro spinning up, it's all is good. And then we see here our M4 2XL that we created, terminated. So before we even got to this screen, although we did kind of pass by and it was still pending for a second, within a second maybe, 100 milliseconds, whatever, it terminated this instance, no chance of lost work. You don't have that an issue of someone going through installing whatever they need to install, et cetera. It's all good, problems resolved. So that's the demo. So let's go back here. I want to say, let's zoom in here, full screen. The most important thing of all, thank you. Thank you, everyone. I appreciate you being here today. I hope you all had a wonderful time. Thank you, and thank you to Alan. And remember to please fill out your evaluations. So, thank you.